In this video, I'm going to go over the last problem of the lecture videos in my open math for statistics. So if we, let's get rid of that, read through the problem, we have Master Foods, the company that manufactures M&Ms. 12% of peanut M&Ms are brown, 15% are yellow, 12% are red, 23% are blue, 23% are orange, and 15% are green. You randomly select 5 peanut M&Ms from an extra large bag of the candies. Round all probabilities below to 4 decimal places. Your answer should look like 0.1234, not 0.1234444 or 12.34%. Compute the probability that exactly 2 of the 5 M&Ms are green. So we can use Desmos to create a little table here. This, we can use our binomial distribution as well. So we can either use the formula, we can use technology to help us and set the boundaries in the appropriate way in the technology, or just look at a table and figure that out too. But I'm going to show you Desmos. I think the videos show you GeoGebra and Excel, so you see those already, but Desmos has some good tools, and I've found a template, well, an example that you can use as a template and put it in your Desmos account, so it has the formulas already written up in there, and you just have to change the values for your particular data that you're given. So I'll show you that one. First, we're going to look at exactly 2 of the 5 M&Ms being green. So for green, our probability is the 0.15. So we're going to just jot that there. Okay, what I'm pulling up here is an example I found in the Desmos database, and it had some different numbers than we have, so I'm just taking those out. And I will provide you a link to a template with just the blank one. So it has all these like little signs, caution signs, because things aren't all in there yet. So we're just taking those out for now. So when we fill this in for ours, we want to have the binomial distribution. We have n is 5 for our problem. The probability is 0.15 for that particular color, green, and then the x, exactly 2, is what we're putting in there. So that just gives us this one value here. We haven't set any bounds to get the table or anything like that. So it just gives us for exactly 2. And how they did this was, you can look down here and see all the formulas that they typed in. That should look kind of familiar to you. But it's nice, we have a template. If we want to get the whole table in there, we would have to put in some more info and have our bounds and things like that too. But for now, we're just doing that first problem. And we get 0.13817, so on and so forth, and I wanted it rounded to 4 places. So the answer is going to be 0.1382. So I have that written in here, 0.1382. You would type it in and check your answer. This is just a screenshot here. Now we have to look at compute the probability that 2 or 3 of the 5 M&Ms are green. So we have to figure it out for 2, and we also have to figure it out for 3, and then we would add those together. So we've already figured out for 2. So now we just need to go back into Desmos and figure it out for 3, and then you're just going to add those together. So you might want to try doing that, getting the template set up and everything, and do it yourself, or whatever method you're using. So I'm just going to go in here and change that last value to 3, and I'm going to get 0.02438, and so I'm going to add those values together. Okay, so now we add those together and we get 0.1626. That was the probability for 2 and the probability for 3 added together. Okay, so now we're going to look at the probability of having at most 2 of the 5 M&Ms are being green, and then we're gonna, the next ones are looking at like the at least situation. So this template is pretty cool. It's more involved than just having exactly one, which we could do for the first thing, but this sets up the binomial distribution values with a slider. So I entered in 5, and then because that's the most that we'll have, that's our total pool. Then I put in the 0.15 here, and my lower and upper bound for probability is always 0 up through 1. And then I also had to pick these values down here. So this is important. So I would have, my lower bound would be 0, and my upper bound is 2. So if I didn't have those in there, this wouldn't come out to the right answer. Okay, it might just give me, you know, exact, it wouldn't actually probably compute anything. Like if I didn't have, it'll just give me an error. So you have to put the 0 in there and the 2 in there. And then the neat thing with this template also is you do get the entire table here. So if you want to generate that, and look, it says undefined after 5 because we don't have any data values, and these are just the formulas that go along with checking out. Like if I add up all the probabilities, they do equal 1. Here's your formula for binomial distribution, and this is you know, just the way the variables have to be defined and things like that. So on this answer for number 3, well, it's part 3 of this same problem, is 0.973388. So we'll go ahead and write that in our answer box here. 0.973. What did we have for ours? 3, so 3.4. You want to round. The next one, compute the probability that at least 2 of the 5 M&Ms are green. So you could use the idea of complement, thinking, you know, well, if at least 2 are green, you could figure out the situation when there's 0 green and 1 green, and subtract that off. Or let's go look at our technology and see. So we want to do at least 2 are green. So looking at our table here, it tells us all the values. So we could just kind of say, okay, well, 2, 3, 4, 5, we could add all those up. It's generated there in the table for us. That's kind of a bit of number crunching there. Or we could figure out what the values are for 0 and 1. We could add those together and then subtract from 1. That would be the complement. Or we could set our bounds here. So on this one, our lower bound would be 2 and our upper bound would be 5. Let's see if that works for us. And the answer spits out right here. Remember, the answer is not going to be down below in the table. You would have to compute that out looking at the table, but using this bounding system, we can do it right there with 0.16479. So we'll round that off and write it over in our answer box. So we get 0.1648 for that answer. The next one is, if you repeatedly select random samples of 5 peanut M&Ms on an average, how many do you expect to be green? So that's what we're looking at, is the expected value. So remember, expected value is you are adding everything up. So that's, but since it's a binomial distribution, it's kind of a little bit easy to do, because we would just use this formula: E of X equals NP. So we really don't even need the technology so much on that one. We could compute that out. So we would do 5 times 0.15, and we get 0.75. So not too bad on that. So remember, because these are binomial distributions, it fits, like it has that yes or no situation or success failure. It meets the requirements, and we don't need to do like the summing up of each individual because it's binomial distribution. Same thing for standard deviation. It's a lot easier to do. So standard deviation of X, the formula for that, just because it's binomial distribution, is NPQ. I've been getting a few questions on this because I think people think they need to do it according to the table and all that, but you actually don't. It's not too bad. So we have, I have to put the square right there. 5 times 0.15 is our P. 0.85 is our Q. That's always just the complement of P. And that's going to be 0.80 M&Ms. So that is our average, which is the same as expected value, and our standard deviation. Okay, so that is in terms of the units would be M&Ms, just to make sure we have that there. It's here already for you. You don't type that into your answer box in My Open Math. And I hope that helps go through this problem. I know people were having some questions about like what to do there, especially on those last two. But I wanted to show you how to use Desmos with the other problems as well. Just that template, you might like it. You can, just whatever technology works for you is good. And in this problem as well, there is a detailed solution that writes out, like, I think it has 3 different methods for you as well. Have a great day.